We're working on the Cartesian coordinate system, also known as the rectangular coordinate system, and we're going to look at linear equations. So for our first definition here, a line in the form of ax plus by equals c is called standard form. And this has the x and y term on the same side, the constant on the other side. And notice your exponents of x and y are 1 in a linear equation. Right? The next definition, a line in the form y equals mx plus b, is slope-intercept form. Right? It has the x and y, the exponents are 1. The y is always isolated in the slope-intercept form. So this one is also a line. And our question just asks which of these are linear equations. So it doesn't matter which form they're in, and they don't actually have to be in either one of those forms. But your exponents of x and y need to be 1, and you don't need any extra notation there. So when we look at these, our first one, y equals 12x. We have x and y. The exponents are 1. This one is a linear equation. I'm just going to write yes or no. Right? And it is actually in slope-intercept form. Your intercept on it is 0. Right? If we're going down, this one is not a line because of the exponent of 2. It's some version of a parabola. You don't have to know that now, but that exponent of 2 makes it not a line. Right? Our third one, it only has an x. But the exponent of the variable is 1. This one is going to be a line. It will be a special line. And we'll come back to that. Right. In our middle column, this one is a line. It has x and y. Exponents are 1. It is in slope-intercept form. Our next one, 7x plus 3 equals 2y. This one is also a line. Exponents of x and y are 1. It is not in either of those forms, but it is a line. Our sixth one, this one is not a line. The absolute value symbols, that's a special type of notation and a special graph. So this one is not a line. On this side, 3x minus 9y equals 12. Exponents of x and y are 1. This is a line. And this is in standard form. Our next one, this one only has a y. It does not have an x, but the exponent is 1. It is going to be a line, and it will also be a special line when there's only one kind of variable. And our last one has x to the third. This is not a line. So you can look at your equation, look at the exponents to tell if it is a line or not. For our next question, what kind of equations are not linear? It is when the exponents of the x and y are not 1, or there is special notation such as the absolute value. Then those will not be linear. There are 3 techniques to graph lines. We can use a method called point plotting or a t-chart. We can use intercepts, which are special points which plug in zeros, or we can use slope in 1 point. When you know slope in 1 point, that is actually the fastest way for most graphs. But for our first couple, we will do point plotting. So for this one, we'll do point plotting, and what we do is just make a chart of values that make this equation true. So our equation is y equals x minus 3. We're just going to make a little t-chart. And you're going to substitute into the one that's not isolated. So we're going to plug into the x, anything we want, but we have to graph it. So let's say we pick a 0. Pick it, write it down, plug it in. So y equals 0 minus 3 is negative 3. And then you start over. So we're going to pick something else. Let's say we pick a 2. Pick it, write it down, plug it in. Equals negative 1. And let's pick a negative value just so they're spread out a little bit. You do not have to. You can actually pick anything you want. You can't pick a bad value, but you might pick something inconvenient if it goes way off the chart. Right? And if that happens, just pick another one. So we're going to plug in -2 into the x. Watch your signs. Those are like signs. So it will give you a -5. Now we're going to plot these points and connect the dots. So 0, -3. Don't go over, but go down 3. 2, -1. Go back to 0, 0 to start. So 2, over, down 1. And -2, -5. So back to 0, 0. -2 on the x, -5 on the y. 1, 2, 3, 4, 5. Your points should line up, and we will draw a line through those points. For our next one, we will also graph by point plotting just to make sure we have some practice with that. This one is a perfect setup for slope if you're used to slope. If you are, then do slope. Right? But we will do point plotting, so we'll make a little t-chart. Again, we're going to plug into the x because it is the one that is not isolated. Anything we want. So I'm going to pick a 0. 0 is nice because it makes the math easy. And then you plug it in. So y equals -3 times 0 plus 2, which gives you 0 plus 2 is 2. Right? And then we'll pick a 1. So y equals -3 times 1 plus 2, which will be -3 plus 2 gives us a -1. And we can pick a -1. So y equals -3 times a -1 plus 2. Negative times negative will give you a positive. So this will give us a 5. Now we'll plot those and connect the graph. So 0, 2. So we start at 0, 0. We don't move over, but we move up 2. 1, -1. Go back to 0, 0. 1 on the x, -1 on the y. And back to 0, 0. -1 on the x and +5 on the y. 1, 2, 3, 4, 5. Those do line up, and we will connect the dots to make our line. And it's supposed to go right through those. For our next method of graphing, we're going to use some special points called intercepts. The x-intercept is of the form where we have x and 0 for the y. So to find the x-intercept, you're going to let the y equal 0. The intercepts are points where the graph crosses the axes. So to find the x-intercept, we will let the y be 0 and solve for x. For the y-intercept, this is the point where the graph crosses the y-axis. It is of this form, and to find it, we will let x be 0 and solve for y. This technique for graphing using the intercepts is nice when your x and y are on the same side of the equal sign. For this problem, we are told to use intercepts to draw the graph, but just looking at our equation, it would be a good choice with x and y on the same side to use intercepts, even if they didn't tell us what to do. One other thing to point out here, when we did point plotting, we picked 3 points. 2 points actually tell where a line goes. The third point is a checkpoint. When we do intercepts, because they have a built-in check of knowing where they're supposed to land on the x and y axis, you can get away with just 2 points. So we'll make a table. And if we want the x-intercept, we're going to choose 0 for y. So write it down, and then we'll plug it in. So 2x plus 5 times 0 equals -10. 5 times 0 will cancel out. 2x equals -10. Divide by 2. X will equal -5. So that's our x-intercept. And then we will switch and plug 0 into x, which will give our y-intercept. So 2 times 0 plus 5y equals negative 10. 2 times 0 will cancel. We have 5y equals negative 10. Divide by 5. I'm just going to go ahead and do it since I'm out of room. 5 into negative 10 will give you a negative 2. And we will plot these. They should land on the axes by definition. So start at 0, 0. Negative 5 on the x. 1, 2, 3, 4, 5. And up 0. Go back to 0, 0. And it says don't go over, but go down 2. And then we will make our line. For our next one, we're also told to graph using the intercepts, but it would be a good choice because x and y are on the same side of the equal sign. So we'll just do it in a little table form. And remember, we're going to pick zeros. So if I pick a 0 for x, pick it, write it down, plug it in. We'll make this piece cancel, get 6y equals 6. Divide by 6, y equals 1. Right. Then you're going to switch and plug 0 into y. So you're always choosing a 0. So negative 3x plus 6 times 0 equals 6. This one cancels. Negative 3x equals 6. Divide by negative 3. So you will get x equals negative 2. And we'll plot. So start at 0, 0. For 0, 1, don't go over, but go up 1. That's a y-intercept, lands on the y-axis. And then our next one, go back to 0, 0. Negative 2 on the x, 0 on the y. X-intercept lands on the x-axis. So they land where they're supposed to by definition. And we will connect the dots to draw our line.